Okay, so we are getting ready for exam 1 right now. This sheet just has the formulas that we've learned so far. So I want to go through them and make sure we understand when we use these formulas. You're welcome to print out this formula sheet and take notes on it and use it on the test. I just want to make sure we know all there is to know about each of these formulas. So these two right here are for histograms, which was chapter 3. With the histograms, this is what we were using before we moved to the normal curve. So let me just write some notes down here for you. So let's say we have a histogram, and on this histogram we have a bunch of bins. So let's say this is 10, 15, 20, 25. And this bin is 1.6 tall. So this on this side, it's the percents. So when I say 1.6 tall, I mean it's 1.6% tall. I do not know how to erase. I had known how to erase. Oh well, it's just gonna stay there. Oh no, this has to be the eraser, right? Yes, it is. Okay, sorry, technology issue there for a moment. Then let's say this next bin is 3.6% tall, and this bin is 1.1% tall. So these formulas that we had up here are dealing with finding the area or finding the height. So with the area, keep in mind there's probably a lot more to this. This is just the first few. So if I want to know the area, whoops, area is not spelled with an N at the end. Sorry, I don't know what that was. If I want to know the area between 10 to 20, what you need to do is multiply the width times the height. So for 10 to 15, the width is 5. The height is 1.6. So you do 5 times 1.6. But we're not looking for 10 to 15, we're looking 10 to 20. So now I need this next area, 15 to 20. Well, that's also 5, but it has a width of 3.6. So then we can multiply that out. 5 times 1.6 plus 5 times 3.6 is 26%. So what that means is the area from 10 to 20 for whatever this histogram represents is 26%. So 26% of the population studied falls between 10 and 20 of whatever this is. So that's this formula. You can also use area equals width times height. So let's use this section, and let's say the rest of the section has to be, or the rest of the people have to be in this section. I'm just making this up, so I don't know how beautiful this is going to be. We'll find out. What I want to know is the height for that section. And we know that the total amount has to add up to 100%. What we're missing is all but 26% of that. So we're missing 74% of this total area. So if I want to know the height for the bin that goes with this section, that's 10. We're looking for the height. So the formula is area divided by width. So I'm going to do the area divided by the width. We know the area has to be 74% because that's what's missing. The width is 10 because we're going from 25 to 35. That's a width of 10. So that leaves us with 7.4%. So this bin has to be 7.4% tall. Okay, so actually that doesn't really need the percent there because the rest of it doesn't have the percent. That's what you do with width times height and area divided by width. Those two formulas are dealing with the histogram. On the test, there are questions about histograms, so you want to make sure you know what those two formulas are for. The questions about histograms are pretty easy though, so if you understand what's going on here, you'll be just fine. Okay, let's look at the next formula. So let me erase all this. Okay, we've covered these dealing with histograms. I guess I should not have erased those or that info. The next is Z. Okay, Z is called the Z-score. You are standardizing when you create the Z-score. It's also called standard units. And what it's finding is how many standard deviations away from the average that specific score is. Okay, so all of those are different ways to refer to the Z-score. The most common are Z-score and standardize. With this Z-score, typically if you're finding the Z-score, you're going to go on to shade norm. And with it, what you're looking for is typically the area under the curve. So let's do an example where we have to use Z-score. And I'm going to use the ACT test. So let's say on an ACT test for the math section, the average is 23. Actually, that's pretty high. Let's not do that average. Let's do the average is 20 with a standard deviation of 3. Okay, I want to know how many or what percent of people who took it got less than 25. So when you're given a question like that, you're going to have to use Z-score, but we have 3 steps we have to do to get to that. So the first step is draw your normal curve. Whoop, that's a really tall normal curve. Let me fix that. Speaking of normal curves, you've probably seen a lot of normal curves as people have talked about flattening the curve for the COVID-19 stuff. That's what this is. The normal curve is that how many people have it over what period of time is what you're looking at if you've seen those normal curves. So what we have here is the average is 20 with a standard deviation of 3. I'm looking at 25. And I want to know the percent of people less than that. So I'm going to shade in this area underneath 25 because it is less than. I don't know why it just did that. Let's try this again. Well, I'm not going to use that shade tool. Sorry, that's a mess. Okay, so that's step 1. Draw the normal curve. Step 2 is to calculate the Z-score. And that's why we're doing this problem, because here's the formula for Z. So Z equals the entry. In this case, our entry is 25. Entry simply means like, what number are you looking at? What's the number you care about right now? Then we're given that our average is 20 Our SD is 3. So if we type that into our calculator, 25 minus 20 divided by 3 is 1.6 repeating, so I'm just going to round it to 1.7. With the Z-score, you don't really have to go out to 2 or 3 decimal places. You can choose whatever you want there, as long as you use at least 1 decimal place. So here's what Z equals. What that means is we are now looking for the percent under the curve of 1.7 standard deviations above average. So to find that, we use shade norm. And go negative 10 to 1.7 to 0 to 1. And type that into your calculator. Sorry, I'm working on my iPad and I haven't downloaded a calculator app on this yet. I'll have to get that done in a minute. So I am typing it into my calculator. You can't see it on this. Sorry, I'll get that done before I make the next video. So we have negative 10 is the lower bound. So what I'm typing in looks like this. Lower bound is negative 10. And remember, we use negative 10 because we're going off to the left forever. So we just need a large standard deviation. 1.7 is the upper. We keep it at 0 and 1. So your calculator should automatically have this fancy M as 0 and this symbol as 1. Remember, this means average, this means standard deviation. Just know that they always stay 0 and 1. Okay, gonna type that in and then hit enter. If you don't have your window set correctly, that's okay. It'll still give you the correct answer. If you don't remember what your window should be, look at the calculator instructions sheet and you can get your window fixed. It's negative 3 to 3, negative 0.5 to 0.5 with a scale of 0.1. If that means anything to you, great. Otherwise, look up the calculator instructions sheet. So I'm getting 0.95543. We're going to round that to 95%. Actually, I'm going to round that to 95.5%. So what that's saying is 95.5% of people who took this specific ACT scored a 25 or less on the math section. Okay, I just made that data up, so I don't know if that's accurate or not, but that's how we do a problem similar to this one where it's asking for a percent under a curve using the Z-score. Okay, so that's our Z-score. The next formula we need to look at is the RMS error. Okay, RMS error is dealing with linear regression. So linear regression, we started that with chapter 8, maybe. With linear regression, you'll be asked to predict some y value based off of an x, and you'll plug it into a like y equals mx plus b formula. And then you'll be asked, how much is this prediction likely to be off by? Sorry, handwriting's not great on this. On the test, that is how it's going to be phrased. You will have a problem like this dealing with a scatter diagram, and then it will give you a formula for a linear regression, and then you'll be asked, how much is this prediction likely to be off by? That means use the RMS error. And to do that, you're just going to have to plug data in. So you'll be given a 5-number summary. You'll be told the average for the X is some number. I'm just going to make numbers up. So it's 30 with a standard deviation for the X of 5. The average for the Y is 42 with a standard deviation for the y of 7. With the correlation coefficient of 0.72. Okay, so you'll be given some data that looks similar to that, probably different numbers though. And when you're asked this question, how much is this prediction likely to be off by, you just plug it into this formula. The square root of 1 minus r squared times the standard deviation of y, and then you just type it into your calculator. When you type it in, make sure you put the 0.7 or the 7 outside of the square root so that your calculator does it correctly. So I'm going to do the square root of 1 minus 0.72 squared times 7 is 4.86. So make sure you put the units on that, whether it's points or inches or whatever unit it might be. But that's how you do a question that says, how much is this prediction likely to be off by? If you're taking notes, you probably would want to be doing this on the back by now. I'll bet you're out of room on the front of the page. Okay, the next thing is slope and intercept. And I'm going to add a formula to this, and that formula is y equals mx plus b, where m is the slope, b is the intercept. When you're doing this, you're going to be given information about a scatter plot and asked to create the line of best fit or the regression line. So you'll be given a scatter plot as well as a 5-number summary. And with that 5-number summary, let's see if I can remember that one we had up before. Average of x is 30. SD of x is 5. Average of y is 42. SD of y is 7 with an R of 0.72. Okay, you're given that information. You're going to need to plug it into these formulas to find the y equals mx plus b equation. So our slope will be equal to r times SD of y over SD of x. So r is 0.72 times SD of y is 7, SD of x is 5. 0.72 times 7 divided by 5 is 1.008. And I'm just going to use all 3 decimal places there. The intercept, the reason I'm using all 3 decimals is because 1.008 is slightly different than 1. So I want to make sure I show that it's not just a 1-to-1 relationship there. It's not a rise 1, run 1 relationship. It's almost that though. The intercept is the average of the y minus the slope times the average of the x. So 42 minus 1.008 times 30 is 11.76. So you will have y equals 1.008 x plus 11.76. That is the formula you'll use. You'll be given information like maybe x is the midterm, y is the final. So you'll be able to know which variable is which. On the test, I think you're actually I know you're given the formula, so you won't actually have to calculate this formula. But it's good to just review the steps so you know where the formula comes from. Okay, that's our formula sheet. If you have questions about any of these formulas that I went through, please let me know. Thanks for watching.